Hello everyone, welcome to today's video on circles. So we're starting a few lessons on circles. So we're going to have a slightly different format today. I'm actually going to show you a video embedded in this video of a really good description of the parts of the circle and then getting to the idea of what pi is, because there's some graphics that this video can do that I don't really know how to do, and I'm not going to remake the wheel, circular wheel, to do that. So we're just going to start with that and then we will get into some practice problems.
You probably see circles almost everywhere you turn. But mathematically, what is a circle?
Good question.
Well, in geometry, a circle is defined as the set of all points that are equidistant, or the same distance, from another single point. And the best way to understand what that means is to see it in action. So, here's a single point to start with. And now, let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one, also a foot away, but in another direction, right here. Now let's make another, right here.
And another, and another, and another, and another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as the set of points that are equidistant from a center point. But of course, we usually don't see it as a set of points because there's infinitely many of them, so they form a continuous circle. Okay, now let's learn about the parts that make up a circle. First of all, we have the original point that we started with. That's called the center, or the origin of the circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle. That distance is called the radius. The radius is important because it's the distance from the center of a circle to any other point on the perimeter of that circle. And even though a circle only has one radius dimension, you can draw as many radius lines as you want to. Usually you'll only see one radius line drawn since it's the same length no matter where you draw it. Another important circle dimension is called the diameter. The diameter is the distance across a circle. If you start at one point on the circle and then draw a line straight through the center to the other side, that distance is the diameter. As you can see, the diameter is really just the same as two radius lines drawn in exactly opposite directions. So for any circle, the diameter is always exactly twice as long as the radius. All of the equidistant points we drew combine to form the perimeter of the circle. Remember that perimeter is just the distance all the way around a shape. But because a circle is a special shape, the perimeter of a circle gets a special name. It's called the circumference. The circumference is the distance all the way around a circle. We're going to learn how to calculate the circumference of any circle in the next video. We'll also learn how to calculate the area of any circle. But before we can learn those things, we first need to learn about pi. Grog make pi.
Not that pi.
Sorry, Grog, not that kind of pi. In math, the word pi, which is spelled pi, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? That's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. A ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. 2 diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close! 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat.
All right, so pretty fun. Okay, so those are the key parts of a circle. And then we have pi. So as the video did a really great job explaining, pi is equal to the ratio of my circumference to the diameter. So we know it's a fraction, right? With ratio, we can write it as a fraction. Fraction bar means division. Okay, so this means you can always get pi by taking the circumference of a circle and dividing by the diameter of a circle for any size circle, which is why pi is so cool. Okay, that's when my math geekiness comes out. I love the number pi. So now we want to figure out the formula for circumference. So what we're going to do is we're going to think about how can I solve this equation that I have written for C? How do I get C all by myself so I can easily find the circumference? Well, like I'm solving an equation, I'm going to ask myself, what's currently happening to my circumference, to C? C is being divided by D. So how do you undo dividing by D? How do you undo dividing? You multiply. Okay, so if I multiply both sides by D, then the D's are going to cancel away, and I will get that circumference is equal to the diameter times pi. Or more frequently, you'll flip it around, and you'll see this written as circumference is equal to pi times diameter, pi d. Okay, so that's going to be the formula now I can use if I'm giving the diameter or I'm given the circumference to find the other part. Okay, there's one other version of this equation, which involves the radius. I can just replace that diameter d with 2r, 2 times r. Okay, because I know the diameter is equal to 2 times the radius. So we're going to end up using both of these equations. These are both the formula to find the circumference of a circle. Awesome, now let's look at some practice problems. So sample 1 asks, what is the circumference of a basketball hoop that has a radius of 2 feet? So I kind of attempted to draw this. So a basketball hoop is a circle. Thus, we can find the circumference, that distance around the circle, based on the radius. All right, so let me redraw my circle. Here's my basketball hoop. This is the center of my circle, and I'm told that my radius is 2 feet. And now they're telling us, find the circumference. So I'm going to look at my 2 formulas. What's my given information? My given information is that radius, okay, which I've been using red for the whole time. So which of my 2 circumference formulas involves a radius? Yeah, the second one. C equals 2 pi r. Okay, so I'm going to rewrite that. So now what I need to do is I need to substitute my given information into this equation. So I am given that the radius is equal to 2. So r equals 2. So that means where I see r, I can substitute into, and it's normally going to do that in parentheses. Okay, so when I substitute that in, it's going to look like this. I'm just replacing or substituting in 2 for r. And now I could just evaluate this. I want to find the circumference, c, and c is already all by itself. It's an isolated variable, so all I have to do is figure out what's going on the right-hand side to get my answer. First, I'm going to get this answer with keeping pi in it, which you will often do, and that's the most exact answer. Because pi is rounded, often you'll just leave pi in the answer. So on this right-hand side, I have 2 times pi times 2. So let's ignore pi for a second. Order doesn't matter. What's 2 times 2? 4. Okay, so I get 4, and then I still have times pi. So I have 4 times pi. So this is an accurate answer. The circumference of this circle is 4 pi feet. But that might not help you too much in terms of understanding what that actually means. So often we'll go a step farther and actually multiply by pi. So if we were at school, sometimes there's like a pi button, which is nice, but we can also just use the abbreviation that this is 4 times, or not the abbreviation, the rounded number, 3.14. I actually technically would not use an equal sign. I would use this like approximately equal to sign. It just means I'm no longer an exact answer, but it's pretty close. And then we would do 4 times 3.4, and we will get 12.56. So 12 and 56 hundredths feet. So that is the circumference, or the distance around a circular basketball hoop. All right, now we're going to look at one example where we're given the diameter and we need to use that to find the circumference. All right, now let's look at example 2. So it says, what is the diameter of a circle with a circumference of 27 centimeters? Use 3.14 for pi. Okay, so we're trying to find the diameter. You always want to ask yourselves, what are they giving you and what are we trying to find? So we're trying to find this diameter, which is going to be d, given that the circumference is 27 centimeters. Okay? All right, so I can use my formulas to figure that out. Which of my formulas has both the circumference, c, in it, and the diameter, d, in it? This one, the top one, or the bottom one? The top one, right? The circumference is equal to pi times diameter. So I'm going to rewrite that. Okay, and then let me just quickly get a drawing of this. Circumference is 27 centimeters, and I'm trying to figure out what is the length of that diameter, that line straight across through the center. Okay? So now I can use my formula to figure this out by substituting in what I'm given. So I'm told that the circumference is equal to 27 centimeters. So that means where I see my circumference, I'm going to substitute in 27. And then the rest I'm going to keep the same. Right, at this stage, this is where it gets a little bit harder than the last example. I need to ask myself, okay, I'm trying to find the diameter. We want to solve for d here to figure out what is the diameter, what's the missing value. So you have to ask yourself, okay, what's currently happening to d? Just like I'm solving an equation with multiplying or dividing. What is currently happening to d? Well, d is getting multiplied by pi, right? D is right next to pi, that means multiplication. This is pi times d. So how do I undo multiplication? Division, right? So I'm going to undo multiplying by pi by dividing by pi. Okay, so I can find d by dividing both sides by pi. When I do that, on my right-hand side, I'll have pi divided by pi. Pi divided by pi, just like any other number in the whole world, is equal to 1. It goes away. Any number divided by itself is 1. So that goes away, and I just get d. And then on my left-hand side, I have to do 27 divided by pi. They're telling us here, though, that they want us to use 3.4 for pi. So I could also write this as 27 divided by 3.14. Okay, so quickly, I just put this up on the right. You don't have to copy this down. Normally, people would just use the symbol pi, even if they're rounding when they put it into the calculator. But the idea is we're just using 3.14 for pi. So d is getting multiplied by pi, or 3.14. So how do you undo multiplying by 3.14? You divide by 3.14. Okay, so you do that to both sides. And then when we go on our calculator, we do 27 divided by 3.14. You get 8.598. They don't tell us what to round to. We'll make it easy for ourselves. We'll round it to the tenth. That's 1 decimal place. The 9 here is going to round my 5 up to a 6. So this is going to be approximately equal to 8.6. 8.6 centimeters is going to be the diameter of a circle when your radius is 27 centimeters. Okay, and I'm just going to give you 2 problems to do yourself. Okay, so for you, try 1. This is going to be similar to our first example. What is the circumference of a circle with a diameter of 20 feet? Okay, so you should have gotten 20 pi feet or 62.8 feet. Okay, and then we have you try number 2, which is like my second example. What is the radius of a circle with a circumference of 20 feet? All right, and you should have gotten 3.18 feet. Good job, everyone.